Relative error and percentage error. When calculations are being made, errors can occur, especially calculations which involve rounding. It is important to have a measure of the error. So here are some definitions or formulas that you want to learn off. So error is equal to the modulus, so these lines here mean modulus, which means the positive value, of the true value minus the estimate value, and is always considered positive. Relative error is equal to the error divided by the true value. Percentage error is equal to the error divided by the true value multiplied by 100%. So basically the relative error multiplied by 100%. Accumulated error is the collected inaccuracy that can occur when multiple errors are combined. So for accumulated error, for example, if you were trying to come up with the area of a piece of wood, a rectangular piece of wood, and you measured the length and the width, and you rounded off the length and the width, well, when you multiply that, you're compounding your error. So if you have rounded off the length and rounded off the width, then when you get an estimate for the area, you have a further error in your area because you're multiplying two rounded values. The answer to 5.6 plus 7.1 was given as 12.5. What was the percentage error corrected 2 decimal places? So our true value is 5.6 plus 7.1, which is 12.7. And the estimated value was 12.5. So the error is going to be the modulus, which means the positive value, of the true value minus the estimated value, which is 12.7, the true value, minus the estimated value, 12.5, which gives us 0.2. And 0.2 is already positive, so we just get an answer of 0.2. But if we come up with a negative answer here, we would just automatically make it positive. So the percentage error is the error divided by the true value multiplied by 100%, which is 0.2, divided by 12.7, multiplied by 100%, which is 1.57%, corrected 2 decimal places. A shipbuilder needs sheets of metal to be 2 meters long by 1 meter wide, but will accept sheets which are 2 meters plus or minus 3 millimeters by 1 meter plus or minus 2 millimeters. So they're allowing for an error of 3 millimeters for the 2 millimeter length and an error of 2 millimeters for the 1 meter length. Part 1. What are the dimensions in millimeters of the largest sheets and the smallest within the given tolerances? So to help us out, we're going to draw a sketch. So the blue shaded rectangle is 1 meter by 2 meters. Now obviously this is not to scale. So this is what the shipbuilder needs. He needs metal 2 meters by 1 meters. So we have 2 meters by 1 meters. So the blue rectangle is what he wants. So the shaded part shows the desired sheet. So the blue part shows what he wants. The larger outline shows the maximum sheet, while the smaller outline shows the minimum sheet. We're going to have a look at this in a bit more detail now. So the shaded part shows the desired sheet, so that's the blue part. But the larger outline, so what I've now highlighted in yellow, shows the maximum sheet. So we start off with 1 meter, and we are told that we are allowed an extra 2 millimeters. So we can add on another 2 millimeters. Now this is not to scale. And then for the 2 meter length, we are told we're allowed an extra 3 millimeters. So there's our extra 3 millimeters. It's labelled there, but obviously this is 3 millimeters as well. So this is the size of the maximum sheet. Now let's have a look at the minimum sheet. So again, remember the shaded part shows the desired sheet, so the blue rectangle shows what we want. And now the smaller outline, which I've highlighted in yellow, shows the minimum sheet. So if this was our 1 meter, which is the length that's desired, we are allowed to now take 2 millimeters off that. So we can subtract 2 millimeters from the 1 meter. So here we have the 1 meter length, and if we take off 2 millimeters, this is the length that we're left with. So again, it's not to scale. And likewise then, the 2 meters, we can take off 3 millimeters. So if this is 2 meters, right up as far as here, and this is 3 meters, then up as far as here is the minimum length. So highlighted in yellow is the minimum sheet. That's the smallest the sheet can be. So question 1 says, what are the dimensions in millimeter of the largest sheets and the smallest within the given tolerances? So dimensions mean the length and the width. So let's start off with the maximum. So the maximum length is going to be the 2 meters plus the 3 millimeters. So the 2 millimeters desired plus the 3 millimeters, which is really 2000 millimeters plus 3 millimeters, which is 2003 millimeters. The maximum width is going to be the 1 meter plus 2 millimeters. So that's the 1 meter desired, and then we add on an extra 2 millimeters. That's allowed. So that's really 1000 millimeters plus 2 millimeters. It should say 2 there, not 4, which gives us 1002 millimeters. So the maximum dimensions are going to be 2003 millimeters multiplied by 1002 millimeters. Now let's have a look at the minimum length and the minimum width. So the minimum length is going to be 2 meters minus 3 millimeters. So the 2 meters is what's desired, but if we take off that 3 millimeters, we have 2000 millimeters minus 3 millimeters, which is 1997 millimeters. Now for the minimum width. Again, the desired length, width is 1 meter. And if we subtract the 2 millimeters, we have 1000 millimeters minus 2 millimeters, that should say 2, which gives us 998 millimeters. So the minimum dimensions are 1997 millimeters multiplied by 998 millimeters. Part 2. Calculate in meters squared the difference between the area of the largest and the smallest sheets. So we need to change from millimeters to meters, and we do this by dividing by 1000, because there's 1000 millimeters in a meter. So we want to convert the 2003 millimeters into meters, and that's 2.003 meters, and the 1002 millimeters into meters, that's 1.002 meters. So we divide it by 1000. So the maximum area is going to be 2.003 meters multiplied by 1.002 meters, which is 2.007006 meters squared. So this is the maximum area, and we got it by multiplying the maximum length by the maximum width, which we worked out in the previous part. So next we're going to work out the minimum area. So this should actually say minimum. So again, we're going to convert our minimum length into meters and our minimum width into meters. So 1997 millimeters divided by 1000 is 1.997 meters, and 998 millimeters divided by 1000 is 0.998 meters. So multiplying 1.997 meters by 0.998 meters, we get 1.993006 meters squared. So this is our minimum area. And the difference in the areas we just subtract, and we end up with 0.014 meters squared. So just a reminder about relative error and percentage error. These are some of the definitions or formulas that we used in these questions, and they do need to be learnt off by heart.